Hi everyone and welcome back to another BTLO Replay. Before we jump into Pandemic, be sure to follow us on Twitter or join the Discord server to keep in touch with the BTLO community. Links are in the description box below. Right, so let's get started. As always, we're going to have a look at the scenario first and then walk through some of the questions. The second wave of the pandemic started. Cybercriminals also started their second wave of attacks. Here comes the new phishing technique. Alert, alert, alert. There are masks to safeguard yourself from the pandemic, but do you have a mask on your PC? Our OS vendor released a new Pandemic Saver update, which will act as a mask to safeguard yourself from the pandemic. Immediately download the attachment and run the update. Quick! As a malware analyst, your IR team approach you to decide whether the attachment is safe or not. If it's safe, provide the IOCs. Malware sample and necessary toolkit is available on the desktop. So I'm going to click start here, and then we'll come back, look through the questions and the tools. So we're going to be using Regshot. So that's a tool that we can use where what we do is we run the tool first, and it takes a snapshot of the registry, and then we run our sample, and then we run Regshot again, and it will show us the differences that have changed on the system. Now, Windows is very noisy, so we will get a lot of stuff that is not relevant to the malware or the sample that we're looking at, but that's okay. Next is Sysinternals. PEView is a static analysis tool. So looking here, what is the text written on the icon? So we're probably going to have to open up the favicon file to have a look at that. Compile date and the packet used. So that's likely in PEID as a static tool. Netcat server IP address. This could be actively running, but maybe not in this lab. So we would need to find it stored somewhere. The message you get after executing. Stuff like this is really good if we can get a hash of the file and then use open source research to look for it, either on something like VirusTotal, Joe's Sandbox, something like that. Where are the keylogs stored? So it looks like it's a keylogger. Where's the new file name of the malware after executing? So it must replicate itself. There's a registry key, command and control IP address. This will likely be an OSINT because it won't be active. We don't have active internet within the box, so we're not going to get it unless we can get it out of static analysis or dynamic analysis even, if it's stored in the sample somewhere. Name of the system process which the malware is injected. And then this one will definitely be open source research, probably based on anything else that we find. So we're likely going to be getting the hash, doing some open source research. Let's jump into it. So quick look at our toolkit, and we'll have a look at the malware sample as well. Okay, so pretty extensive toolkit. We've got Regshot. We should have PEView, sorry. So it's there, just hasn't been extracted yet, but we can extract it. So let's just do that now. Let's extract that here. Don't want you to show me. And then we've got Regshot as well. And if we have a look behind here, we will have the malware sample. So it looks like there's a little icon there. Let's have a look. What else do we have in here? Resource Hacker is another good tool that we could use. Let's jump in. Let's use PEID. Let's see if we can answer some of the earlier questions first. So I don't want to run it yet because we need to set up Regshot, and we will do that to get some of the answers for sure. So I should be able to drag. No, it's not letting me drag and drop. So let's go open. I want to go back to desktop, open up the sample. Let's have a look at it. And can I make this bigger for you guys? Let's go to 18, I reckon. It's probably a good size. All right, that's pretty good. Let's go from here. So I want to drag this open. I'm guessing this, if you're watching this video, it shouldn't be your first time seeing kind of like the structure of an exe file. We do have some earlier labs that go through this stuff. Let's have a look at the questions and see if we can answer some of this. So what do we want to do? We want the compile date and the name of the packet used. So we're just going to kind of step through this program. and have a look what's in here. Whole bunch of information in the header. There's nothing about the compile time. Let's have a look further into the headers. So we've got a signature here. So this will be the PE is a signature for an executable file. We've got a date timestamp here, which could be the compile time. I'm actually pretty sure this is the compile time for it. Looks like it's been spoofed 1992. And then the packer name we actually won't get in this, but let's see if we've got maybe some other static tools that we could use. Yeah, so PEID, I've often used this for getting the packer names because it'll try and do a best guess. So let's open up that. PEID. This might also give us the compile time as well, which would be a nice comparison between PEView. All right, so we got PEID up. Let's go with the file that we want to do. So we'll go back to desktop, sample, and pandemic survivor. So we've got EP section. So UPX is a type of packer for samples or for binaries that we've got. So that's likely the packer. It doesn't look like it's given us the compile timestamp, but we know that we only need the date, month, and year. So let's go with that. So for question 2, let's go with, it was 1906, 1992, and then UPX as the packer. Sweet. So just to refresh there, we got the timestamp from the image file header using PEView, and then we got the packer using the EP section for PEID. All right, next one is, while we're using all these tools to do analysis and we've got them all at our disposal, let's have a look. Another one that I really like to use is Resource Hacker. These are all part of your static malware triage toolkit. So let's extract this one out. All right, so we've got Resource Hacker open. Let's again open our sample. So we'll go through to the malware sample. It's got an icon folder in here, which is awesome. Let's see if I can, looks like I can't make this bigger. I've got preferences. All right, that's a little bit better. Let's make this bigger. Pull it across to the questions. Let's have a look at the icon, because this was question number 1. So if I just select it, here we go. So what have we got in here? Just going to step through. Don't know whether I have to click on this. Oh, here we go. So we're starting, looks like we've got different potentially layers, and then we've got different sizes of the icon. There we go. We got a nice clear one there. So COVID mask is on the icon. So this is question number 1. Let's type in COVID mask. And that's our correct answer. Awesome. So that was the usefulness, I guess, in using Resource Hacker. Okay, next question. What is the Netcat server IP address and port for 5 points? So let's have a look and see what other programs we have that we could use. There's the full Sysinternals suite. Okay, so let's go back to PEView. There's probably not too much more in here that we get at this point, because this is packed. So because it's packed, we're not going to get easy strings out of the file. So we probably want to run the sample and then capture as much as possible on the system, see if it drops some files, see if it's communicating, that kind of thing. So what I'm going to do now is I'm going to set up Regshot and then run the sample. We'll check netstat through command line, and then we'll see where else we can go from there to answer any more of the questions. So first thing is, let's get a command line up because we're going to have to run netstat. All right, so that was just a test. We're going to run a netstat ANO to see if we get any connections. These are all the connections for the lab to work. It is unlikely that we would see it in netstat, but we are going to try CLS to clear. And then we'll have netstat ready to run when we run the sample. Normally when you would do this, you would have your own VM set up, you would have all your tools, you would kind of have a snapshot with Regshot and everything ready to go, and then run your sample. Similar to kind of like how sandboxes work, is it gets everything ready, will detonate the sample, or run detonators running the sample, and then it collects all the information and gives you a report out at the end. So from here, let's go into the Regshot folder and let's run this version. So you can see here, we take our first shot, we take our second shot, and then we compare the two. The other thing that we can have running, now that I think about it, because we have Sysinternals, let's extract this to a folder. Don't want to extract all because it'll just drop it all in here, and I don't want that. Let's make... make a Sysinternals folder, and then I can extract it into that. The tool that I'm interested in using here is Procmon, or Process Monitor. Process Monitor will actively capture everything that's happening with the sample, which could be really useful for stuff that's too quick to, well, not too quick, but won't go into the registry or is just running in memory. So we can get some stuff there. So let's get Procmon up. Let's agree to the terms. All right. So the first thing I want to do is I want to stop the capturing, which is this one. Yeah, capture. So that's stop. When it runs, it automatically captures. Let's see if I can make this bigger as well. Options, font. Let's make this 18 as well. So you can see here on a Windows machine, lots and lots of things are happening all the time, just running in the background. So that was only running for like maybe 10 seconds. And we can also already see a whole bunch of stuff. So what we're going to do is we're going to clear all this. When we're ready to run the sample, I guess my process of events is I'm going to do Regshot, and then I'm going to start my capture, and then I'm going to run my sample. I'm going to let that run for a little bit. I'm going to stop my capture, And then I'm going to do my second Regshot and compare. And then we're going to look at the Regshot first, and then we'll come and look in here. And we can do a whole bunch of filtering on the list of processes to just really drill down to the process that we're interested in. The other method is we will filter out everything that we're not interested in, because the sample may change PID, like it may inject into another process, it may change its name. So we want to make sure we're not filtering out stuff that we actually need for our analysis. So the first thing we're going to do is clear, which I think is this one. Yep. So we've cleared that out. Let's now take our first Regshot. So the three main windows that we want to have ready, and I'm going to close this, but we want our malware sample, our process monitor, and our Regshot. So the first thing we're going to do is we're going to take our first shot. So shot. What this is doing is just going and scanning the current state of the system in the registry. All right, so our first shot is done. Next, we want to start our capture and then run our sample pretty quickly after that, leave it running for a while, and then we'll come back and stop the capture. So let's start the capture. The next thing, make sure we're running the sample as administrator, because we want to give it all the permissions to do everything that it needs to do. Otherwise, it may not run effectively. So it looks like it ran. We could take a screenshot of this. So congratulations, Pandemic Hero. You took the step to protect your PC with this mask. I actually think that's one of the questions. I'm just going to go OK. We're letting it run for a while. We can see we're getting lots and lots of events. There's already some default filters in here because we can see that it's only showing half of it. All right, so I think that's pretty good. Malware normally runs pretty quick. There could be a sleep in here somewhere, which we may need to run it for longer, but we're doing a first pass. So again, if you were doing this yourself, you would run it quickly, do some analysis. If you think there was a sleep in there that you want to monitor, you would then run the sample for a longer time and keep procmon running longer. But we're just going to click to stop the capture. So we got close to 900,000 events, which is pretty awesome. And then what we're going to do is do the second shot now. So we'll go second shot. While that second shot's going, we did get a screenshot of that. Congratulations. So let's have a look through the questions. So it's actually this one. It wants the window title and the Windows body. So from the screenshot, it was congratulations, Pandemic Hero, ! You took the step to protect your PC with this mask. Sweet. So that was an easy one. We just needed to run the sample to get that one. All right, so our second shot has now finished. What we're going to do is click compare. So this is saved it as two separate files, and then the compare will kind of mush those files together and show us only the stuff that's changed on the system. Like I said at the start, this will still be very noisy because Windows itself in the background is very noisy. We're kind of only interested in operations that a user would be doing and maybe seeing like what keys would be running or installed somewhere or anything that looks out of the ordinary. This really comes down to like how much you know the Windows system, which is a lot of the time in malware triage or reverse engineering. So let's zoom in a little bit. And then I think word wrap. Let's do some word wrap. Times like this is when I really enjoy very large monitors. And I think I don't want to do a word wrap at this point in time, but let's make this bigger. So we've got a key added here, COVID updater. It's nothing special at this point in time. We can go have a look at the values updated. So this could be for persistence. So it looks like there's something added in program files here, an MS update, important update, COVID updater. That could be interesting to go have a look at. Values modified. So this could just be a lot of Windows modifying stuff. User assist is kind of the user actions that happen on a Windows system. There's a lot of information there, but not really necessarily to do anything with the malware. I'm going to skip over that for now. What we're looking for is quick wins. So we're not super interested in everything. So we've got values added, keys deleted. And that's all we've got. We've got this important update, which could be which question was that? So this could be the COVID updater that could be the registry key run, which was question 7. What is the value of the registry key used to maintain persistence? It is COVID updater. So let's have a look at that one, see if we can get that one. COVID updater. Right. Okay. So it's not that. Let's have a look for the new file name. So question 6, the new file name for the malware after executing. That, I think, is this. So it's saving itself and calling itself this. So let's try that. Okay, so important update.exe, we're correct there. It's interesting that this isn't the registry key. We may need to dig further into that. Could be by persist, but I doubt it. I think these are like settings within those keys. So we just answered question 7, which is fine. No, question 6, sorry, we just answered. Let's have a look at the program files. Let's see what else, if anything else was dropped in there. So we're heading to program files x86, and then program files x86. Was there anything else? MS update is what we want to look for. So we don't have a MS update in here. Hidden items. Nope. Those added. So what could have happened is maybe we didn't run the sample long enough. So while I'm doing this, let's go back to the sample. Run as administrator. All right, so that sample's running. All right, while that's running, let's have a look at the procmon output. So let's open this up. So what we're still looking for is question 3. What is the netcat server IP address? Let's go. Let's see. Well, actually, let's see if netstack gets us anything now that the sample is running in the background. So nothing. There's a time wait here, but that's just localhost. That's not really going to help us. The rest of those IP addresses were the same. Okay, it's not super helpful. Let's have a look at our file operations. So here we can do some filter. Actually, let's filter out for the stuff that we don't want and then go from there. So we're not so much interested in registry keys. So let's exclude registry keys because we've got that in Regshot. So we don't necessarily need it. We're just kind of interested in the file events surrounding our sample at this point in time. All right, now that the registry key has cleared, that took a little while. Let's see if I can just filter out all registry events. I want operation. Begins with, and then let's do reg, and we want to exclude. Then let's add that and apply. That should remove all of our registry keys. Great. Let's close this. So now we have a whole bunch of stuff. Let's filter out ms-mp-eng. That is the scanner for Windows, or one of the security executables. We don't need that. I will be back when this finishes. I'm not sure how long it will take. All right, so now that we're back, we've filtered out all the registry keys, and then we filtered out the security process. There's probably still, like, we could filter out this node.exe. We might want to filter out, so we still want to filter for just kind of the files. So what I'm going to do is filter out again for this TCP operation. So let's go architecture. Come on, this thing is slow. Operation is, no, we want to go begins with, and then TCP, we want to exclude, add, and apply. Okay. All right, so there's also some UDP here, but let's see what we can see. Let's see if we can search. So we want to look for the pandemic process first, because that's what we ran. So let's search down. So this is a pandemic survivor. I'm going to close the questions. And let's make this larger. So this is kind of when the sample started running, and we had this going. As you can see, Windows does a lot of API calls to do all of these things. So what we're looking for is kind of this changing to pandemic survivor, and then doing something on the system, whether it's creating new files, interacting with something. Obviously, at the moment, we're mostly getting, we filtered out the TCP stuff, so we might need to add that back in. But we're looking for just extra things that we can go search on to give us the next hook into this investigation. So all I'm doing is scrolling down. CSRSS process. Still quite a lot. I'll keep scrolling. I'll come back to you guys when I find something interesting to highlight. So here we're seeing consent.exe. So this is, we're still early in running the sample, because consent.exe is the program that runs on Windows that has the pop-up window that says, do you want to run this sample? So we're going to keep scrolling past this. I'm actually now going to exclude consent.exe because there was a lot of it. I'll also probably then exclude SVC host next, and then we'll come back to it. All right, now we're back. We've filtered out the SVC host process, and what was the other one that we filtered out? It took so long that I forgot. process value. Oh, consent.exe was the other one we filtered out. If this wasn't so slow, we could filter out a lot more. Like I would filter out this because this is to do with the lab running. Let's filter this out and then I'll be back again. All right, so we now filtered out that other process. Let's keep having a look. It's taking considerable time to filter out each of these, so it's difficult whether I want to keep looking, keep filtering out, or just keep looking. So let's keep looking for the pandemic process and see if we can find some stuff. So we're getting a process create, a process start. This is looking good. Let's keep looking down here. So some stuff that has nothing to do with the pandemic one. And then this is the executable actually running. This is good. So like I said, this is good. We're seeing the process to start to run. What we want to see is some system interaction now. So we're just going to keep scrolling. It's loading up all of its import DLLs to run. This is a standard process for what Windows executables do. We're seeing a thread create. This is not to do with the program itself. We're then seeing it's creating a file. Program files internet.exe. We did not see that in the program files directory though, and we're showing hidden files, so potentially deletes that later on. It's then looking like it's running iExplore. So we're seeing that thread start. So it looks like iExplore is being used in this program as well. So we should see it shift across to iExplore a bit more soon. So we're getting more thread creates, it's injecting into it. It's loading up the DLLs again. Notice here, so syswow 64 is the 32-bit version on Windows. So it seems to be using the 32-bit DLLs. That can escape some monitoring sometimes just because it's not as heavily monitored. We're seeing some thread exits, more DLLs. I'm just going to keep scrolling. When I find something interesting, I'll cut into it to explain it. All right, so because we're seeing still a lot of stuff, what I'm actually going to do now is I know that it's using iExplore and the pandemic survivor one. So we're actually going to filter just for those two. So I'm going to filter this one in, include pandemic savior version 1. And then I'm also going to go in and include probably explore.exe and also iExplore.exe and see what we get from there. So I'll cut back into the video once I get those filters up and running. All right, so just to show you here, I'm adding the pandemic process, which we already did, that auto did it, and then Explorer and iExplore, and then click apply. This will run for a bit and then we'll come back with all the results. Okay, so that was pretty quick to do those two. So this is where we're up to. Let's keep looking through now. So we can see that a file was created, ms update. But again, we didn't see that in the program files, or am I just missing it? See program files. No, so ms update isn't in here, which is interesting. So maybe it was deleted. That was the important update that we saw, which is fine. So towards the end, we probably should see a file deletion for this. Let's keep going through. So seeing ms update plugin.dat, that could be interesting. So let's make a note of that. If we keep going. Explorer is interacting with it quite a lot. So I'm just going to keep scrolling. I'll cut back in if I find something interesting to share. So what I'm going to do is I'm going to filter out this path because I'm actually not interested in it. All right, so we've removed that pandemic sample. I'm just going to keep scrolling again, and I'll cut in if I find something interesting. Pandemic looks like it's doing something in C Windows, which could be interesting. Let's keep searching for it. All right, team. So what we're going to do is we're going to restart the investigation because I want to run the sample again and run it for longer this time before interacting with the pop-up that happened with the congratulations. I want to see if it will drop some files while it's running as well before we clear that. That might be the catalyst to getting rid of some of the files. So what we're going to do is try and see, we know that the C program files x86 directory potentially had some files in that MS update folder. So we're just going to see if we can find some of that stuff. And then we'll run Regshot again, see if there's some other information there. Some of the times when you run samples, you might miss something the first time, so you do have to run them again. I guess the downside in this is that we need to restart the whole lab rather than just reverting a snapshot, but that's okay. I'll jump back once I've got everything set up and we'll step through running all the programs again, just as good practice, and then we'll continue on from there. All right, and we're back. So I've opened up the 32-bit process monitor this time to give that a try because I know that the process is calling all the 32-bit DLLs. Shouldn't make too much of a difference. I've also tried the Unicode Regshot, and we're going to see how this goes. So I've already done the first shot. What we're going to do now is run the malware, and then we're going to navigate into the program files x86 directory. And we also saw that it was interacting with the Windows directory from the last look. So we're going to have a look in there before we dismiss the pop-up that happens. Because once we dismiss that, what it might be doing is cleaning itself up and removing a whole bunch of stuff. So let's run this as administrator again. Remember, this will run that consent.exe. So we've now got that in the background. Let's now go to the program files x86 directory. We should be seeing that update folder. We're not seeing that. It was the MS update folder that should have been populating in here. Let's check normal program files. So again, it's not in here. If we go back, I haven't enabled the hidden files yet, but let's go hidden items. So we should now, yep, we're viewing hidden items. Still not seeing anything there. Let's check in the Windows directory. Elam backup, we didn't see that. I don't think that's anything. Scrolling down to see if anything sticks out. Let's see if MS update's in here. It's not. And then a lot of this looks standard for Windows. Let's go back. Program files. Just make sure I'm not missing anything. Let's go MS update. No results. That's fine. What if I go back to C and then we're still interested in looking for the MS update? Turn on index. Yeah. The other thing I didn't do is I didn't do the capture. So we may need to run this again, but I'll quickly do that after we do the second red shot to see if anything comes up. This is the I explore. The pop-up is what it's using. All right, so it looks like it's not populating anything. What I am going to do, let's just stop this. Let's stop the search. Didn't find anything. Let's do a second shot, and then we'll come back and we'll do a compare. All right, so we've popped open the compare now, and we're just going to see if there's anything different here than we didn't have last time. So top one is deleted. We're not that interested. Keys added. Let's see what we've got here. There's a lot more, but we had it running, like we had a longer time period in between when we ran the sample versus stop, then doing another Regshot, the second shot to capture it. So we should expect to see more changes on the system. I'm not interested in classes. I also went and checked. We still don't have that MS update folder that we saw in that first Regshot. Current version, we want to see if there's a run key. Let's go back up. So Control F for, we want to go up, and we want to search for run. It's going to show me runtime, which is not what I want. Should be able to go /run. Find next. There's a run once key. There's a run key there. Explore run. Okay, it's not really necessary. Let's go to the bottom of the file and go from there. Total changes. So we're seeing quite a lot of changes this time, which is difficult to search through when you've just got notepad.exe. So these are values modified. So what did we have before? We had the important update. Important update. Oh no, we would have a look for the MS update again, right? Because we saw that. We want to go up. Let's see if we can find that. Nope. Why is that trying to run it? Cannot find MS update. What was that? Cannot find. Show details. So we try and search for MS update, and then it tries to run it. I wonder. Keeps trying to run. Okay. Interesting. Okay, so it was hidden. So now we see, let's just let it run. That's fine. It's a dat file. So let's have a look in here. Notepad. See if we can open it. Let's go back. So we definitely don't have MS update in here. But if we typed it in, so it's hidden even from when you show hidden items. Right, so I typed Defender. So this is the keylogger. This could be the answer to one of the questions, right? Which was question 5. What is the name of the file where the keylogs are stored? So footprint.dat. So let's go try that. Footprint.dat. All right, so we've got question 5. What was the question we were trying to search for? I think it was the IP address, right? Question 3, what is the Netcat server IP address and port? All right, so we've got that one. That probably solves this question. What I would be interested in is that C Windows directory that it was interacting with. So if we go Windows /, let's see if it turns up in here. There will be a lot. So this is probably not useful. Doing it this way. Yeah, likely not. Okay. I wonder if we search in command line and do a directory listing that MS update directory would show. So if we change into C, program files, and do dir/a. Right, okay, so the MS update is in here. Interesting. So if we cd into MS update, we can see if there's actually anything else. So the executable is also in there, which we found. So it's hiding from the GUI, but not from command line. Let's change into C Windows. And then do dir/a. Let's have a look for anything. This looks interesting. So we saw that it was interacting with that directory and dropped it. It's a batch file, so it should be running something. So let's go, the cat equivalent on Windows is type. Awesome. So now we've got the netcat one. So if we go back, we now have question 3. So format 172.16.104.128. And then the port is 445. Excellent. Okay. So we got quite a lot there all in one go. It was a mixture of the 2 Regshots that I ran and looking through the process monitor. So I saw that the pandemic savior or the iExplore process that it had injected into was interacting with both C Windows and the C program files x86 MS update. And then it was hidden from us on the file explorer, which was really interesting. I actually don't know how it managed to do that. But if we go into here, so we know that it's not in program files, but if we look in Windows, I don't think that batch script showed up in here either. Oh no, the batch script is in here. Okay, so we could have still looked at the batch script, but the MS update folder was completely hidden from us. All right. The registry value, so we're now moving on to question 6. The registry value was an interesting one. So that was when we ran the last Regshot. So where is my Regshot again? Output path. So this is my Regshot. The last time we looked for COVID update, I think it was the registry key that was added. So let's have a look again. See if there's any other registry keys. COVID updater. Servers right above it's interesting. Let's keep looking. Yeah, so this should be the registry key. So maybe this is, what is the value of the registry key used to maintain persistence? Oh, I suppose the value could be the important update.exe. It's not asking for a full path. Was that it? Is it update? No, just update.exe. Okay. So it wants the program, which is the value within the registry key. So the name of the key is COVID updater, and then the value is important update.exe. All right. Next is, I think this will be mostly OSINT for the third last and the last question. And then the other question that we want to answer is, the process that it was injected to. So we did see that was iExplore from procmon. So we can go iExplore.exe. Excellent. Yeah. So we knew that from the procmon from the last time we ran up this lab. And then next step from here is, I'm probably going to close this. I don't think I need this anymore. What we're going to do is hash the important, I needed that. We're going to hash the important.exe binary, and then we're going to search for it online. And I will come back to that in a sec. All right, so we've got 2 more questions to go. We have question 8, which is, what is the command and control IP address? And then the malware found to be a well-known remote access Trojan or a rat. What is the name of it? So like I said, well, let me extend the lab. Like I said, so we've run the sample now. We want to go and look at that important update.exe, and we're going to take a hash and try and find it on VirusTotal or Joe's Sandbox or somewhere else, and see if we can get the C2 address from there. And then, especially from VirusTotal, we might be able to find the name of this sample or the family of rat that it comes from. So let's do that. Once command line loads, I'll be back. All right, so we've got command line. We need to navigate into, I think it was the program files directory, sorry, into the MS update. Yep. And then no, not ls. The important update should be in here. Maybe all because they're hidden. Important update is gone. Okay. So we might be able to get a hash of the original sample. So if we go back and into users, users, BTLO test, desktop, and then malware sample. The sample has also deleted itself, which is not great. Okay, so what I'm going to do is have to restart the lab, run it, look at the important update, get a hash of it before it deletes itself, and then go from there for authent. So I will see you guys back when I have this up and in command line and then run the sample to get the important update. All right, so here we are back now. I've restarted the machine. I've got command open. Our aim is to run it and then capture the hash for the important update exe. So let's go ahead and run this as administrator. Let's go yes. That's going to run. We're going to get the update. I'm just going to leave that in the background. And then what we're looking for here is we're just seeing for when the MS update kind of drops into this directory. So I'm just going to keep running a dir /a because it should appear in here. All right, maybe if we click, let's click OK. There we go. We've got the MS update. So let's cd into the MS update. Run a dir a again. So we've got the important update file there. Now we're going to use cert util and we use it as a verb. So hash file, important update, and we can copy in this box. So this will be easy if we do SHA-256. Highlight that, right click to copy, and then let's go to VirusTotal. Jump into here. Let's do a search and we'll drop the SHA-256. So we can see that it's malicious, important update. I'm just going to look through the signatures here to see if anything sticks out that's not kind of just standard malicious. I'm looking for the name that it could be within these because sometimes it does have it. Public could be an interesting one. Artemis is another one. No, it's a Trojan. So if I go public malware, also known as Pakai bot. So I'm just going to open up that one. We can look at public. Just looking if anything else stands out here. We're going to do a bit more research. Let's open up another one. Artemis malware. This is a blog on how it defines it. So let's have a look in here. Okay, up here. Right, okay, so it's not the name of the virus. It's just a generic name that it uses. No, nothing really there. Popular threat label, Trojan Mint Zard. So we can also look for this. So we've got Mint, Zard, Public, all family names that we could try. And because it thinks it's a name, malware, Trojan Mint Zard. Reddit could be interesting. Let's have a look there. Banker Trojan could be because it's keylogger, bot spyware. Okay, so we've got some more here. We can try all these and see if it works. Let's have a look at the details. UPX packed, which we knew, so could have done that. Ran the sample, got the hash, got it here. We've got the creation time, which we got right. Important update. Some more hashes of this stuff. Let's go relations. So it could be this address. Contacted domains. There was no detections on it. Okay. So we've got behavior. Nothing else is immediately standing out to answer the rest of our questions. So what we're looking up here, contacted domains, it didn't have anything. DNS resolutions. So it could be this IP. We could go and try that. Copy questions. Nope. What we could do is look at one of the sandbox reports. So I think access that through here. Might need to go look it up. Oh no, here it is. Display sandbox results. Community. What does community say? Threat name Cybergate. And it's got Joe's sandbox. Okay, so Cybergate's another thing that we could look for. Let's look at the HTML report. So what I want to try and answer first is the C2 address before I start guessing family names of the malware, I guess. So similar icon, injecting into iExplore. C2 lists. This could be the IP. So this kind of looks very similar to a Cobalt Strike. Okay, so what it wanted was the C2 address from the configuration file. So the install, this fits with everything. Cerberus version. Let's go Cybergate Cerberus version. It seems that Spynet version code was used for the base of the service wrap family, mirroring Spynet 2.6 and Cybergate. Okay. So we know we're looking for a rat. And remember way back, we did see, I think it was a registry key that had Cerberus as the key name. So that could be where we need to go with this. So I'm having a quick squiz through this blog. Right. Okay. So it looks like it could either be Cybergate or Cerberus based on the Joe's sandbox. Doesn't say threat name Cybergate, but then this is saying Cerberus. So my first instinct is to go with Cerberus, since that's the software version that we're looking at. So let's try that. Awesome, and we're done. Okay, so that took a little bit of work to get to there. Let's quickly summarize where we're at. I just want to recap because this was quite involved. The lab was slow. It took a lot of time to get through. I had to restart 3 or 4 times to get everything. I'm not sure whether you would have seen all those cuts, but this took me quite a lot of time to get all the answers together. So the first question is, what is the text written on the icon and the malware icon? So to get that one, we used a program called Resource Hacker, which showed us the resources in the executable, and we were able to open up the icon directory and then look for a clear picture of the icon, which showed us COVID mask on the mask. We then moved into compile date and name of packer. We used 2 programs for that. So we used both PEView to get the compile time from the headers within the sample, and also PEID, which then gave us the packer of UPX. We also saw if we hash the sample first and then looked at virus total, that gives us both of that, the answers there in the details of the sample. The Netcat server IP address and port, we saw that it was dropping files to both the C program files x86 MS update folder and the C Windows. And for the Netcat server, I think that was for that was in the C Windows, and it was a batch file called touchmeagain.bat. And in that folder, in that file, when we looked at it, it was NC, which is Netcat, TACV 172.16.104.128 space 445. That's where we got that answer. The message you get after executing the malware was just a pop-up on the screen. You could probably get that from sandboxes. They usually take pictures as the malware is running. The footprint.dat was in the MS update folder, and that's the keylogger. We actually saw it logging some of our keys, and it was stored in that DAT file. You could just open it up in a text file, and then what is the value key? What is the value of the registry keys used to maintain persistence? So with Regshot, we saw that COVID updater was a key name made, and then it pointed to the important update.exe, and what it wanted here was the name of the file, I guess, or the name in the key that was going to be run. For some of these other ones where we saw things pop up on the system, where I got that was both in either Regshot or I also saw it in Procmon early on as well, which led me into the Windows C directory and the program files x86. The last thing that we saw on the system, so definitely in Procmon, we saw that the pandemic savior executable was injecting into the iExplore process, which is what popped up the little screen notification about congratulations. And you could also see that when you looked at virus total or the sandbox reports. The C2 address, that took a little while to get. We guessed the first time, but then we ended up finding it in the Joe's sandbox. So if we look back over here, the C2 list was a single IP. And then we also got the last question, which was the version. So the threat name being Cybergate, which has its own rat, but then the sample, which was the hash match. So remember, we got the hash of important update to link it to virus total, and then also get this report. We then got the Cerberus version, software version being used, which indicated that this was a Cerberus rat. And that got us to the end of the lab and fully completed. So not too difficult. I think this was a medium rating. It just took a long time with the lab and having to restart it. Yeah, with your own malware analysis, you're normally able to restart or go back to your snapshots to then easily run the sample again. So it was just because we needed to terminate the lab and get it back on that it took a while. But very close to what you would do in a job. Got to use a lot of tools, which was fun. Really good lab to do. So thanks for watching. Be sure to like and subscribe to never miss a video. In the meantime, remember to join us on Discord and tune in every Friday at 6 p.m. BST for BTLO Replay. Thanks everyone, and I'll catch you all next time.